Hello, welcome to Special Relativity. We have seen how the electric field transforms from one reference frame to another. We have also seen what the electric field of a moving charge looks like. Let's now study the effect of the electric field of an electric current acting on a moving particle. From our course in electricity and magnetism, we know that electrical currents generate magnetic fields. Electromagnets are all around us. The magnetic field B of an electric current at a distance r of a point P is given by B equal to mu naught times I over 2 pi r, where mu naught is a fundamental constant, the magnetic permeability of vacuum. This constant is related to epsilon naught and the speed of light, through c squared is equals to 1 over mu naught epsilon naught. The magnetic field follows the rule of the right hand that indicates the direction of the magnetic field. The magnetic field lines are closed loops around the current, where your thumb points in the direction of the current and your fingers curl in the direction of the magnetic field lines, going current this way, magnetic field that way. A moving electric charge in a magnetic field experiences a force, the Lorentz force, given by F equals to Q times V cross product B, where Q is the charge of the particle, V is the speed, and B is the magnetic field. For example, if an electron moves anti-parallel to a current-carrying wire with current I, then the forces it experiences is because of the cross product. For a charge moving parallel to the current, we have that at the point where the particle is, the magnetic field points up, and so the cross product of V times B points against the wire. But because the electron has negative charge, the final force will be attractive. Well, that said, let's have a closer look. From the perspective of the laboratory, we observe a current and an electron moving anti-parallel to the current. So the electrons in the wire move parallel to the flying electron. Let's call beta the speed of the test Dr. electron and beta naught the speed of the river-song electrons in the wire. From this lab frame, let's consider that the density of charges in the wire is 0. We have the same density of positive ions as density of negative electrons. The density of ions is lambda naught, and the density of electron is negative lambda naught. Of course, if this is the case, the density of the river-song electrons in their own reference frame should be less. Should be lambda naught over gamma naught. If gamma naught is the contraction dilation factor due to the relative speed between the negative electrons in the wire and the ions in the wire. In the lab reference frame, our test electron is moving at beta because the electron is moving and we have an electric current. The electron will experience Lorentz force, but not electric Coulomb's force, because the net density in the wire is 0. Let's have a look at the perspective of the electron. From the moving electron reference frame, the ions in the wire are moving to the left, and the electrons of the wire are moving at a speed beta naught prime. We need to apply a length contraction to the line of electrons and to the line of the river-song electrons in the wire. For the ions, we have that the density has increased due to the length contraction to lambda positive equals to gamma lambda naught. For the electrons, we need to calculate the speed of the electrons as seen from our test electron reference frame. Call it beta naught prime. We apply addition of velocities, so beta naught prime is equals to beta naught minus beta over 1 minus beta beta naught. This gives us a gamma prime such as Now it's turn to calculate the density of electrons and the density of ions in the wire, as observed by our flying Dr. Electron. Lambda prime is gamma lambda naught. This is the gamma contracted density of the ions due to the speed of the Dr. Electron. Minus, because of the negative sign, lambda naught over gamma naught. Remember, this is the negative Rivasong electrons' density charge in their own reference frame, times gamma gamma naught times 1 minus beta beta naught. This last term is the transformation factor to the frame of the Dr. Electron frame. So, after this wibbly wobbly timey mathy calculations, because the ions move faster than the Rivasong electrons in the wire, as seen by our test Dr. Electron, is positively charged. So there will be a Coulomb force here. The electric field from the wire is E prime equals to lambda prime over 2 pi epsilon naught r prime, where r prime is the same as r. There is no length contraction in the perpendicular axis. Because the force F prime is equals to Q times EY prime, this is equals to minus, from the charge of the Dr. Electron, Q gamma beta beta naught lambda naught over 2 pi epsilon naught r prime. Remember, this is Coulomb's force, the force due to the electric field. We can now go to the laboratory reference frame back again, that where the ions are at rest. From previous results, E perpendicular is equals to E prime perpendicular over gamma. So the force in the lab frame is minus Q beta beta naught lambda naught over 2 pi epsilon naught r. But it happens that lambda naught times minus beta naught is the charged density times the velocity of the Rivasong electrons. This is the definition of electric current. Remember that beta naught was the velocity of the electrons in the and the current is opposite to that. That's why the negative sign. So we can rewrite all this as F sub y equals to Q Vi over 2 pi epsilon naught r c squared. Again, this is Coulomb's force, the force due to the electric field. Now, let's wrap up. Let's recover the magnetic force. Remember that the magnetic field of an electric current was mu naught I over 2 pi r. But if we use the relation between c squared and mu naught epsilon naught, we get that this Coulomb force is the same as the magnetic force. So we see that the magnetic force is in reality the electric force disguised under relativity. Magnetism is just electricity plus relativity. There is no magnetic force, only electric force and relativity. Electric fields transform into magnetic fields and vice versa. So magneto is just electron running very fast. There is a very nice video going over what I just explained by Derek Muller from Veritasium that goes over the qualitative explanation of all this. I did the nasty part, the math, he does the fancy part. Have a look at it, and may the science be with you.